Good morning, students. Today our session starts with continuation of the last class. Magnetic moment. It is also an important topic regarding the objective, either JEE Main or JEE Advanced. Magnetic moment mean, first of all, let me give the definition. It is the product of pole strength and its magnetic length. So, the product of pole strength and a magnetic length is called the magnetic moment. Suppose let us consider a bar magnet. This is the bar magnet with the south and north poles. Pole strength is M and a magnetic length is 2L. Now, the magnetic moment of this bar magnet denoted by M. M is equal to, it is the product of pole strength into magnetic length. This is the formula for the magnetic moment, and also vector form. M bar is equal to, this is 2L bar into M, where M is the scalar pole strength. In the last class I said M is the pole strength. Pole strength is a scalar quantity, whereas the 2L bar magnetic length is nothing but vector quantity, and this is the vector form of magnetic moment. So, here the magnetic moment, it is denoted by the symbol M. It is a vector quantity and see the unit of the magnetic moment. The unit of the magnetic moment is ampere meter square or joule per Tesla, different units are there, or Newton meter cube per Weber. These are the different units for the magnetic moment. And let me give the dimensional formula. We are very familiar to dimensions. In the first year, you learn much more information about the dimensional formula. Now, the dimensional formula for the magnetic moment. Current is nothing but ampere, unit of the current is the ampere. So, here we represent with I L square or A L square, because current is a fundamental physical quantity, it is represented either I or A. So, do not bother about that. Or if you see the full form is m power 0 L square T power 0 I power 1 or A power 1 is the dimensional formula for magnetic moment. And mainly about the direction. So, direction of the magnetic moment is always from south pole to the north pole, that is SN bar, south to north. So, this about the magnetic moment. Okay, students, in the today's session we started about the magnetic moment. It is also integral part of the chapter magnetism and matter. It is a very important definition and important concept for upcoming JEE Main, JEE Advanced applications as well as the problems. Basically, what is the definition of the magnetic moment? It is the product of pole strength and a magnetic length. Is nothing but magnetic moment. It is denoted by the symbol M, is a vector quantity, and also unit of that one I given, dimensional formula I given, direction is always from south to north. Suppose if you see this one, here it is a magnetic dipole. Why I call it is a magnetic dipole? The bar magnet is nothing but magnetic dipole, because the configuration which having two equal opposite poles having the same strength, they are separated by certain distance, is nothing but magnetic dipole, or it is said to be the bar magnet. So, the direction of the magnetic moment of this one is from south to north. This is the direction of the magnetic moment, is a vector quantity south to north. This is the magnetic moment. And after that, a very important topic for JEE Main and JEE Advanced, exclusively for objective, variation of magnetic moment. Variation of magnetic moment. That means, let us see how the magnetic moment of the bar magnet may vary. Generally, the magnetic moment of the bar magnet may vary by doing these all activities. By cutting the magnet, cutting off bar magnet, cutting off bar magnet. Second one is bending off bar magnet, and the third one is during combination of bar magnets, right. So, the magnetic moment of the bar magnet may vary under these three activities. If you cut the bar magnet into the pieces, during the cutting of bar magnet, magnetic moment may vary. During the bending of bar magnet, magnetic moment may vary, and during the combination of bar magnets, magnetic moment will be changed. So, these all are the three important side headings. Now, let me start the first side heading, cutting off bar magnet. During the cutting off bar magnet, first you have to learn about fundamental formula. We know this is the bar magnet. Suppose I said it is an axial line, the line which is passing through the center parallel to the length is nothing but axial line, whereas it is nothing but equatorial line. About is an x-axis and it is a y-axis. And see, this is the face area of the bar magnet, area of cross section. Suppose if area of cross section change, pole strength also changes. That means, I said in the earlier class, M proportional to A proportional to flux. Suppose if area of cross section made half or made half, then pole strength is also half, flux is also half. Suppose area of cross section made 1 by n times, this is m by n, this is pi by n. This is very, very important. That means flux changes. So, this is a different story, I will explain it later. Pole strength changes, the first point. M changes, pole strength changes during x cutting. X cutting means the bar magnet cutted along the x direction. And second one, you are very familiar to the magnetic length. In the last class I said the poles of the magnet are located not exactly at end of the bar magnet. They are little bit away from the end of the magnet. We find it the distance also. So, these are the positions of the poles of the bar magnet, and the shortest distance between poles of the bar magnet is said to be the magnetic length, denoted with 2L. Generally, magnetic length may vary during Y cutting. Suppose the bar magnet which is cutted along the Y direction, it is made pieces along the Y direction, then magnetic length changes. That is a 2L changes during Y cutting. Keep these 2 points in mind, they helps you a lot while solving the JEE problems. Pole strength changes during the X cutting, magnetic length changes during the Y cutting. Now, let me start the first parameter, cutting of the bar magnet. After finishing that, let us move to bending of bar magnet and finally combination of the magnets. So, the first side, cutting off bar magnet. So, various cases are there and also different model problems are there. I will explain one by one. In the variation of the magnetic moment, first side heading, cutting off bar magnet. Cutting off bar magnet. In that A, assume it is the bar magnet. Bar magnet with the south and the north poles. Pole strength of the pole is M, magnetic length is 2L. Now, this is the center of the magnet. This is the center. It is made two equal pieces as shown in the figure. It is cut into the two pieces as shown in the figure. This is the first piece. This is the second piece. Of course, here area of cross section is A. Area of cross section is not changing. But area of cross section is not changing, but effective length or actual length or magnetic length changes. Because the total length between the poles, it is the 2L. Now, it is made two equal parts. Now, M dash. So, actually what is the formula for magnetic moment? Magnetic moment M is equal to the formula. It is the product of pole strength and a magnetic length, small m into 2L. But after cutting the magnetic moment of each piece, how many pieces will come? Two pieces. Now, they are asking what is the magnetic moment of the each piece? M dash is equal to, now let me write small m dash into 2L dash. Therefore, m dash is equal to, m dash means after cutting pole strength of the each piece. After cutting pole strength of the each piece, here face area or area of cross section not changing, that is why m dash is equal to m only. But there is a change in the magnetic length. 2L dash is equal to, it is made two pieces. That is why what happened? 2L by 2. Now, substitute here, what we are getting? M dash is equal to small m into 2L by 2. But here m into 2L, m into 2L is nothing but capital M. So, the magnetic moment of the each piece m dash is equal to m by 2, m by 2. Keep in the mind m by 2 and m by 2. Now, B, another question. Assume it is a bar magnet. This is the bar magnet. So, south pole and a north pole. Pole strength of the magnet or magnetic pole is M, magnetic length is the 2L. It is the center of the magnet. Now, the bar magnet which is cut along length as shown in the figure. It is made two pieces. It is made two pieces. It is the Y cutting, it is the X cutting. So, area of cross section or face area of the magnet is A. After cutting, now face area become A by 2, here A by 2. Therefore, pole strength, new pole strength of the each magnet M dash is equal to, it is made half M by 2 because face area is half, because M proportional to M proportional to A. If it is made half A by 2, M is also half M by 2. Hence, M dash is equal to M by 2, but there is no change in the effective length, there is no change in the magnetic length. 2L dash is equal to, as usual, 2L. Now, what is the formula for the new magnetic moment? New magnetic moment M dash is equal to small m dash into 2L dash. Therefore, m dash is equal to small m dash m by 2, 2L dash does not change because it is an X cutting. Therefore, if you see m into 2L, this m into 2L is nothing but a magnetic moment. Now, in this case also, the new magnetic moment of the each piece would be m by 2. These are the two different models. Now, let us move to C. Assume it is a bar magnet. So, south pole and a north pole. Here pole strength of the pole is m, magnetic length is the 2L. Now, it is made equal parts, y equal parts. This magnet cut into y equal parts. This is a y cutting. If it is cut into the y equal parts, the question is what is the magnetic moment of the each piece after cutting? Magnetic moment of each piece after cutting. Clear? Is a bar magnet of pole strength m, magnetic length 2L. Now, it is cut into the y pieces. Simply it is made y equal pieces. Simply it is the y cutting. Here face area, what is the area of cross section A? That does not change. So, let us write m dash is equal to m only, but effective length 2L dash is equal to 2L by y, because it is made y pieces. Hence, what about the magnetic moment? Formula for the magnetic moment, m dash is equal to small m dash into 2L dash. Therefore, m dash is equal to small m dash is nothing but m, 2L dash is nothing but 2L by y. Therefore, m into 2L is nothing but again m. Hence, the new magnetic moment, here I write, the new magnetic moment m dash is equal to m by y. Keep all the lines in mind. These all are applications. Before the application, clearly I have given the subject and go through that. D. See this question. Again, assume it is a bar magnet. Bar magnet with a south and a north poles as shown in the figure. Pole strength of the magnet is m, magnetic length is the 2L. Now, it is going to cut along the x axis as shown in the figure. It is made x pieces, x equal pieces. It is made x equal pieces because it being the x cutting. And see here, what about the initially face area before cutting? A. So, what happened to area of each piece? A by n and so on, because it is made n equal parts along the x direction. Therefore, pole strength changes, m dash is equal to, here it is made x pieces, that is why I write a by x only, n pieces mean a by n. So, let us write m by x. What is the 2L dash? Effective length or magnetic length does not change. Magnetic length 2L dash is equal to just 2L. Now, what is the magnetic moment? Magnetic moment m dash is equal to, it is the product of pole strength and a magnetic length. M dash is equal to, this is only m by x, 2L dash is nothing but 2L. Again, instead of m into 2L, let us substitute magnetic moment m. Hence, what about the new magnetic moment? The new magnetic moment m dash is equal to m by x. Of course, C it is the y cutting, D is the x cutting. And similarly, let us move to another question. E. Assume is a bar magnet. This is the bar magnet with a south and a north poles. Pole strength of the magnet is m, magnetic length is the 2m. Pole strength of the magnet is m, magnetic length is 2l. Suppose it is made y pieces, it is made y pieces along the y direction, and again it is made x pieces along x direction. That means the bar magnet of pole strength m, magnetic length 2l, it is made y pieces along the y direction, x pieces along the x direction, both x cutting and y cutting. You have to observe, this is the face area, face area. So, face area changes, hence pole strength also changes. During the y cutting, magnetic length also changes. Both changes we have to accept. Therefore, m dash is equal to, this is m by x, 2L dash is equal to 2L by y. The new magnetic moment m dash is equal to small m dash into 2L dash. Small m dash is nothing but m by x into, this is 2L by y. Therefore, m into 2L, m into 2L is nothing but capital M. Therefore, magnetic moment m dash is equal to capital M by x into y. Capital M dash is equal to m by xy. This is another application. And one more question. If assume it is a bar magnet, so this is the south pole and it is the north pole. Pole strength is the m, magnetic length is 2L. In the earlier case, during the x cutting and y cutting, they are the different. But in this case, now it is made n equal parts. It is made n equal parts. It is made n equal parts along the y direction, y cutting. Similarly, it is made n equal parts along the x direction. So, equal parts made along the x direction as well as the y direction. Now, they are asking what is the magnetic moment of the each piece after cutting. So, let me write m dash is equal to face area changes, that is m by n. Magnetic length also changes, that is the 2L by n. In the earlier case, case E, x cutting, y cutting, they are the different, but here all same only. Therefore, the new magnetic moment m dash is equal to, now the product of pole strength and a magnetic length m dash into 2L dash. M dash is equal to, this is m by n into 2L by n. And actually, if you see, m into 2L is nothing but a magnetic moment m. Hence, the new magnetic moment m dash is equal to capital M by n square. M by n square. These are the various cases during cutting of bar magnet. In the first case, y cutting. Second case, x cutting. In the C, y cutting, y equal pieces. In the D case, x cutting, x equal pieces. E and F, all I explained clearly. And let me solve some problems regarding to the mains. During the cutting of magnet, some problems. First problem, see, this is the bar magnet. South and north poles. Magnetic moment of this bar magnet they given is 30 ampere meter square. Magnetic moment of the bar magnet given as 30 ampere per meter square, Actually, we call this line is an axial line. Axial line means the line which is passing through center of the magnet parallel to the length is nothing but axial line. Now, it is cut into 3 equal pieces as shown in the figure. It is made 3 equal pieces. First piece, second piece, third piece. If it is cut into the 3 pieces, after cutting, what is the magnetic moment of the each piece they are asking. So, it is the y cutting. What is the shortcut formula I said? M dash is equal to m by y. How many pieces they made? 3 pieces. Let me write m by 3 directly. M value they given 30 by 3, that is the 10 ampere meter square. Is our answer. It is our answer. Second problem. This is the bar magnet with the south and north poles. Now the magnetic moment of this bar magnet is 40 ampere meter square. Now it is made 4 equal pieces. 4 equal pieces along the x direction. This is the axial line. Right? It is made 4 equal pieces. This is the first piece, whereas it is the fourth piece. Clear? Now they are asking what is the magnetic moment of the each piece after cutting. So this is the x cutting. For x cutting also I said shortcut formula m dash is equal to this m by x. M by x. M value they given 40 ampere meter square, by x value 4 pieces, so that m dash value new magnetic moment of the each piece after cutting 10 ampere meter square is our answer. So very simple. Keep in the mind shortcut formulas. Recall the subject, then you can easily solve the problems. Now example 3. This is the bar magnet. This is the bar magnet. So south pole and north pole as shown in the figure. Magnetic moment of this bar magnet is 60 ampere meter square they given. 60 ampere meter square. This is the center of the bar magnet. Of course, it is an axial line. Number of times I said axial line means the line which is passing through the center parallel to the length of the bar magnet is nothing but axial line. Equatorial line means the line which is passing through the center perpendicular to the axial line is nothing but an equatorial line. Right. Now it is made 3 pieces along the y direction. This is the first piece, second piece, third piece, and also they made 2 pieces along the x direction. This is the first piece, second piece. Clear? It is made 3 pieces along the y direction. So what about the y cutting? Y cutting, y is equal to 3, x cutting 2. I said shortcut formula, m dash is equal to m by xy. M value they given 60 ampere meter square, 60 by 3 into 2 or 2 into 3, that is 60 by 6. Now you are getting the 10 ampere meter square is the new magnetic moment of each piece after cutting. Then example 4. See, this is the bar magnet. This is the bar magnet with the south and north poles. South and north poles. Now, the magnetic moment of this bar magnet they given as 81 ampere meter square is the given value. Now, it is made 3 pieces along the y direction, 1, this is a 2 and 3. Again, they made 3 pieces along the x direction. This is the first piece, second piece, third piece. Equal cutting, y cutting, x cutting both are same only. Therefore, it is n times, here also n times. I said formula. For that, the new magnetic moment m dash is equal to the formula m by n square. What is the magnetic moment? 81 by n square. N value 3 pieces along the x direction, 3 pieces along the y direction, 3 square. Therefore, it is 81 by 9. So, 9 ampere meter square. This is our answer. Magnetic moment of the each piece after cutting, we have or we find the answer m dash which is equal to 9 ampere meter square. M value they given. This is a bar magnet of magnetic moment 81 ampere meter square. It is made 3 pieces along the y direction, 3 pieces along the x direction. Now they are asking what is the magnetic moment of the each piece after cutting. M dash value they are asking. Nothing is there. So, these are the problems linked with cutting of the bar magnet. Now, let us move to another important parameter. Due to that magnetic moment of the bar magnet may vary, that is the bending of bar magnet. Bending of bar magnet. In the variation of the magnetic moment, cutting is over. Second one is bending of bar magnet. So, different cases are there. Let me start with first case. Of course, these all are the different applications, they are nothing but problems only. See, this is a bar magnet. This is a bar magnet. Magnetic moment capital M, magnetic length 2L. Is a bar magnet of magnetic moment capital M, magnetic length 2L. This is the axial line. Suppose if it is bent into, keep in the mind here O is a point at the center of the bar magnet. It is bent as shown in the figure. It is bent as shown in the figure. That means it is bent at midpoint such that it is making an angle theta. The bar magnet bent into like as shown in the figure. See, this is the north pole, or take south pole, this is the north pole, this is the midpoint. What about this length? This is the L, this is the L, because the total length of the magnet is 2L. And see the angle, this is the theta. And we have to find the new magnetic moment after bending like this. And here, if you make a line, suppose it is an x, it is also x. This angle is half mean theta by 2, this is also theta by 2. And here we have one triangle. See the triangle from figure. Take sine theta by 2. Sine theta by 2 mean, so opposite by hypotenuse x by L. Therefore, x is equal to what you are getting, L sine theta by 2. Generally, what is the magnetic length? Magnetic length is nothing but the shortest distance between the poles. Here 2L, magnetic length 2L or 2L dash, that must be equal to 2x. Now, the new magnetic moment of that combination, that is after bending the new magnetic moment, we have a long magnetized wire or a thin bar magnet. It is bent at midpoint such that it is making an angle theta at the midpoint. Now, the new magnetic moment they are asking, m dash is equal to, you know the formula, small m dash into 2L dash. M dash is equal to, here face area is not changing, face area not changing mean pole strength remains same, m into, what about the 2L dash? This is nothing but 2x. Therefore, let me write small m into 2 into x value, you are getting L sine theta by 2. But you know m into 2L, m into 2L is nothing but capital M. Therefore, magnetic moment m dash is equal to m sine theta by 2. M dash is equal to m sine theta by 2. This is the magnetic moment of the bar magnet whenever it is bent at midpoint such that it is making an angle theta at the center. Now, special cases. special cases. And if you have been observed the special cases, in the first case, the magnetic moment m dash is equal to the new magnetic moment m sine theta by 2. Suppose the magnet is bent such that this is the north pole, this is south pole. If it is making an angle 60 degree, this is the question. 60 degree, if the bar magnet is bent such that it is making an angle 60 degree, that time what is the new magnetic moment? Let us substitute here. M dash is equal to m sine 60 by 2, that is m into sine 30 1 by 2. The new magnetic moment m dash is equal to m by 2. Keep those lines in mind. Similarly, second problem, if the bar magnet bent at a midpoint such that it is as shown in the figure. This is the south pole and a north pole. So, what is the angle here? This is the 90 degree. Now, what is the new magnetic moment? M dash value they are asking. So, before bending the magnetic moment is m. After bending we have to find the magnetic moment. Let us apply the formula directly. M dash is equal to, this is m sine theta by 2, or m dash is equal to m into sine 90 by 2. Of course, sine 90 by 2 is nothing but sine 45. This is m into sine 45 is 1 by root 2. The new magnetic moment m dash is equal to m by root 2. This is the second problem. Similarly, third problem, if theta is equal to 120 degree, if it is bent such that it is making an angle 120 degree, then what about the new magnetic moment? M dash is equal to m into sine 120 by 2. Therefore, m dash is equal to m into sine 60. Therefore, m dash is equal to sine 60 is the root 3 by 2. Hence, this is the root 3 by 2 m. Like that, we can solve any problem based on this application. This is the first problem. Let us move to second application and special cases in the same concept, bending of magnet. B. Assume it is a thin bar magnet. It is a thin bar magnet with a south and a north poles. The magnetic moment of the bar magnet is m and its magnetic length is 2l. This is the center of the magnet. Now, the question is, we have a bar magnet like this, we have a magnet. If it is bent into an arc of the circle, the bar magnet is bent into arc of the circle, what is the new magnetic moment? That is the question. This is the bar magnet. If it is bent into an arc of the circle, what about the new magnetic moment? So, this is the complete circle. Suppose this bar magnet bent into arc of the circle. Here, this is the south pole, whereas it is the north pole. And see, now it is subtending. Assume it is center of the circle. If it is subtending an angle theta at center of the circle, theta, and see this one. And if you make a line here, this is the radius r, this is the radius r. Assume this distance is x, this distance is x, and after dividing this, this is the angle theta by 2, this is the angle theta by 2, and we have triangle. take this triangle from figure. Take sin theta by 2 is equal to, sin theta by 2 is equal to, from this triangle sin theta by 2 is equal to, opposite is x, hypotenuse is r, therefore x is equal to r sin theta by 2. Keep in the mind, x is equal to r sin theta by 2. Similarly, if you take the complete arc, this is an arc of the circle, it is subtending an angle theta, arc length is 2l because the magnetic length here, initially the magnetic length is 2l, therefore it is the 2l, radius is r. From this, angle is equal to, you know formula, arc length by radius, therefore theta is equal to, arc length is 2l, radius is r, and from that let me take r is equal to 2l by theta. Here we have to find the new magnetic moment, that is our concept. So when a bar magnet bent into an arc of the circle, what is the new magnetic moment? M dash value we have to find. Already I said formula, m dash is equal to small m dash into 2l dash. Here 2l dash is nothing but 2x only. Therefore m dash, just you are bending only, there is no change in the area of cross section. So m into, let me write 2x. Therefore it is m into 2 into x value, this is r sin theta by 2. Now instead of r, substitute this one here. Therefore the new magnetic moment m dash is equal to small m into, here instead of r, small m into 2 into 2l by theta into sin theta by 2. Let us alter this one, 2 into m into 2l, let us write like this, 2 right in front of this one, 2 into m into 2l sin theta by 2 by theta. Therefore if you see m into 2l is nothing but capital M. So finally what you are getting, the new magnetic moment m dash is equal to 2m sin theta by 2 by theta. We need this formula, not derivation. For the sake of understanding the formula, I given the derivation, otherwise you need not bother about that. For JEE mains and for JEE advanced, for other competitive examinations, you keep in the mind only this formula, m dash is equal to 2m sin theta by 2 by theta. Now in the continuation, special cases, I will give 2 questions, I hope you can solve them. The case 1, first problem, if theta is equal to pi by 3, then what is the new magnetic moment? M dash is equal to question mark. You can apply the formula directly, m dash is equal to 2m sin, instead of theta pi by 3 by 2, that is pi by 6 by pi by 3. Now you are getting, this is a 2m sin 30, actually sin 30 value 1 by 2 by pi by 3, here 2 cancel out, you are getting 3m by pi is the new magnetic moment. Now I am giving the homework case 2 and case 3, I hope you can solve the question. If theta is equal to 5 by 2, m dash is equal to how much? Case 3, if theta is equal to 2 pi by 3, then m dash is equal to question mark. Case 4, if theta is equal to pi, m dash is equal to question mark. So these 3 homework for you. Again, I hope you can solve the questions. Okay students, in the today's session we started magnetic moment. I completed the magnetic moment. After that, we enter into the variation of the magnetic moment. Magnetic moment may vary during the cutting of the bar magnet, I have explained. After that, we enter into the bending. It is going on. In the coming class, I will complete the remaining applications. Thank you.